All right, the quiz coming up very soon, tomorrow, is going to be on sections 12.0, 12.1, and 12.6. Here's a brief summary of those three sections in case you forgot them. 12.0 was our study of 30, 60, 90, and 45, 45, 90 right triangles. I'll just do a couple quick examples of those just to refresh your memory. In 12.1, we talked about SOHCAHTOA, where the sine of an angle is equal to its opposite side over the hypotenuse. The cosine of an angle is equal to the adjacent over hypotenuse. And the tangent of a right triangle is the opposite side over its adjacent side. So those are the three main trig ratios that we've studied. In 12.6, we talked about parametric equations. And there were two or three, I guess, main areas of focus. One was they gave you an x equals, a y equals, and they were both related to t somehow, right? The thing that you had to do was make a table with x, y, t, where I would give you some values to plug in for t, and you would calculate the x's, and you would calculate the y's. Hopefully that didn't give you too much trouble. It was where you would solve one equation for t, and then substitute it into the other equation. This one's actually an easy one because t is already solved by itself, right? T is in terms of x. So all you would do is take the other equation and make it y t squared. Easy one. The other ones we had like the x equals t plus 2 and y equals x squared. Now, how would you do substitution there? What would you do first? From both sides in the x equation, right? Say, make it x minus 2 equals t. And then in the equation, x with, sorry, thank you, sir. This one should have been t squared. Gotcha. T with x minus 2. Phase of that section where we would do tables of value, then we would try to get one equation in terms of the other. Actually, we had relating x with what? T. Another one relating y with t, and we a single equation x and y. Type of parametric focused on the launch with these formulas, which showed you a certain velocity and its position or its distance at any moment in time. Y, however, would distance traveled, it would calculate its height. The difference there is, why does this exist in the front of gravity? Back down towards the ground. And also, sometimes the object would have an initial height, which is y sub 0. All right? So we are going to do a problem like that. Actually, let's go right into that. Let's pretend that we have a castle and we're storming the castle, right? The only thing we have around to storm the castle is we're going to launch some turtles here, and we're going to see if we could launch these turtles over the castle wall to invade the enemy. All right? So that's my turtle. He's flying through the air already, and I gave you some information. Go ahead and draw this. This is a silly problem, but you're paying attention. So here we go. We can't use fireballs. We have to use turtles. Although the turtle may not make it. So let's see. Let's see. And what we have is perhaps quarter. To be humane, yeah. Yeah. Okay. So here's what we have. We have the catapult 40 feet away from the castle. That's deemed to be a safe distance for catapulting. I don't know if you knew that or not from your war days, maybe. So we have 40 feet away from the castle. Castle, that turret at the top, is that what it's called? That's what it needs to clear. Our gun, because back in the days of catapulting things over castle walls, they had radar guns. We know that the speed at which the tortoise leaves the catapult was 60 feet per second. So that's the initial velocity. And we had our laser protractor telling us that the angle when it left was with the ground, the angle is 47 degrees. Is this enough information to determine whether or not the tortoise will make it over the wall? I think it is. I'm going to use turtle and tortoise synonymously in case I mess up. All right, so yes. Okay. Come up with the formula. The formulas that you should have come up with. It's time to put those formulas. We had to reach. Go to y equals. And here, so you're going to see three. A column with the horizontally. Make it. Now we're going to go into another topic from